Hello, this is me, Ayman Yassin. Welcome to my first episode, which is directed to the AS and A-level students. I'm going to start to solve this past paper with you. Paper 1, multiple choice, February-March 2016. In the description part of this video, you may find links of this video and the past paper as a PDF, and also the mark scheme if you want to practice more at your home. So let me start with the question number 1. Here in the section A, you have, for each question there are 4 possible answers: A, B, C, and D. You have to choose one that you consider to be correct. And in this exam also you will have a data booklet. You may use it. So let's start with the question number 1 now. Which compound contains 2 different elements with identical oxidation state? Here you have two different elements with same oxidation state. That means should be both of them positive or both of them negative with the same oxidation state. So let's see option A. You have HClO, oxygen, it's -1, so the other part should be positive. +1, +1, so you have +2. So both of the hydrogen and chlorine atoms, they have this identical oxidation state. And if you need to apply on the magnesium hydroxide, magnesium, it's +2, oxygen, it's -2, and hydrogen, it's +1. So no one is identical oxidation state. And also for sodium sulfate, here in the sodium sulfate, -2, -8, +6, +1 for each sodium. So here also in the ammonium chloride, the chloride is negative, sorry for that, and NH4, this one -3, this one +1. So the correct answer is A. Question number 2, for the element sulfur, which pair of ionization energies has the largest difference between them? That means you have a gap, and the gap always exists between 2 different level energies, because here large difference. So sulfur, it's in group number 6. That means there is 6 electrons in the outer level energy, and it's in the period 3. That means you have 3 level energies, so it's 2, 8, 6. The first 6 electrons to be removed, they have ionization energy which is very close to each other. Why? Because they are all these electrons in the same level energy. But when you will jump to the 7th ionization energy, you have to go to the level which is closest to the nucleus, to the positive center. That means the difference between the 7th and 6th ionization energy. So the best and correct answer is D. In the question number 3, which ion has both more electrons than proton and more proton than neutrons? So electrons more than proton and proton more than neutron. And you have hydrogen and you have deuterium, the another isotope of hydrogen, and the normal oxygen, which is with 8 proton and 16 nucleon number. So let's start with option A. You have deuterium, 1 proton, negative ion, that means you have gain extra electron, 2 electron, and number of neutron, it's 1. So this one doesn't fit with the statement, because we need, yes, electron more than a proton, and proton more than neutron, but here in this case they are equal. In the other one, here it B, you don't need to think about it, you don't need to solve it, because here the ion, it's positive ion, so it's impossible to have electron more than proton for positive ion. So this one at once we will neglect it. In the option C, you have two elements. Here you have negative, so number of proton of oxygen is 8, deuterium it's 1, so you have 9 protons with 10 electrons, and the number of neutron here 16 minus 8, it's 8, and 2 minus 1, it's also 9. So this option also doesn't fit with option. So this one should be the correct answer. So let's solve it. Here oxygen and hydrogen, you have 9 proton, negative ion, extra 1 electrons, 10 electron, and here the hydrogen, it's the only one element in the periodic table has 0 neutron. So the number of neutron, it will be 8 only, which is for oxygen, and hydrogen has 0 neutron. So this is the correct answer. In the question B, so let's remove this one first of all. In the question 4, which species contains the smallest number of electrons? Now, to solve this question, first of all, write the number of proton of each element. Boron, it's 5 proton. Beryllium, it's 4, sorry. It's 4. And hydrogen it's 1, and helium it's 2. Now for proton you have 5, positive 3, that means you have removed 3 electrons, so number of electrons 2 here again it's 2, and hydrogen gain 1 electron, it's also 2, and the helium here you have positive ion, so the number of electron is decreased, so positive 1, that means you have removed 1 electron, so the number of electrons it's 1. So the smallest number of electrons is helium positive 1. Just let's make it fit to the page. Yes, in the question 5 you have nitric oxide NO and bromine vapor reacts together according to the following reaction. Here the reaction is exothermic. That means the gap between the reactant and the product should be in this side. And the reaction has an activation energy, it's in a positive. And this one should be the gap between the reactant and this is the highest point in the profile diagram. So let's check these diagrams. In the option A, activation energy, it's between the product and this point, so it's totally wrong. The delta H is correct, this one wrong. In the option B, the activation energy is correct, yes, between the reactant and the highest point in this diagram, but the delta H, it's not between the reactant and the product, so this one is also wrong. In the option C, you have the activation energy, it's correct, but the delta H is totally opposite between product and reactant, so this one doesn't fit with the value here, which is negative. So this one is the correct answer, as we have explained. Negative, this one, reactant, product product, and this is activation energy between the reactant and this point. So the best answer is D. In the question number 6, which series shows molecules in order of increasing bond angle? So increasing, so from the smallest to the biggest, small to the biggest. So methane, it's 100, actually 109.5, I think that. Just let me double check it, please. Yes, it's correct. And BF3, it's 120, and ammonia, it's 107. So this one doesn't fit to the smallest to the biggest. For H2O, it's 104.5, carbon dioxide 120, and BF3, sorry, carbon dioxide, it's linear, so it should be 180, and BF3 120. This one also doesn't work. Option C, ammonia, it's 107, methane, it's 109, and carbon dioxide 180. So this is the correct option, which is C. Let's do the last one. It's 107, 109, and H2O, it's 104.5. So this is wrong. So the best answer is C. Next question. Let's clean this. Okay. Here, what's the volume of steam produced when 1 gram of ice is heated to 323 degrees Celsius at pressure of 101 kilopascal? Here, this equation, it's related with this equation, PV equal nRT. Temperature is known, R is constant, 8.314. Number of mole, we can calculate it easily because we have 1 gram, and the ice, it's H2O. Pressure, it's already given, 101 kilopascal, but you need to convert it into Pascal time 1000, and this temperature 323 plus 273. So at once you need to find the volume. So volume equal 0.1000. This one in a Pascal, but we don't need to write it in the equation. And number of mole by dividing 1 gram over 18, the molecular mass of H2O, which is 0.055. So here 0.055 time the real gas constant 8.314 time the temperature, which is 323 plus 273. So by calculating the V, you will get it in the cubic meter. Sorry. You will get the result in a cubic meter. Then you have to multiply it by 1000 to get the cubic decimeter, and you'll get the option C. So only you have to make this calculation. Question 8. In the question 8, it's a little bit tricky. You have solid carbon dioxide. It's similar to the solid iodine in its structure and properties. Carbon is in a group 14, and silica, which is silicon dioxide, is a group 14 compound. So, which statement about carbon dioxide and and silicon dioxide? So the question, it's not between the carbon dioxide and iodine. The question between carbon dioxide and silicon dioxide. So both solid exist in a lattice structure. This is correct. Both of them they have lattice structure. Both solid have a simple molecular structure. No, because the carbon dioxide it's a simple, but silicon dioxide it's giant. Actually, it's not simple. Both solids have atoms joined by single covalent bonds. Now carbon dioxide it's bonded with 2 double bonds. In the silicon oxide, yeah, it says correct. Okay, and this one, it will be as a tetrahedral. It will be bonded with another oxygen here, another oxygen from another element. Okay, and in the D option, both solids change spontaneously to gas at standard condition. This statement, it's applied for carbon dioxide and iodine. Yes, both of them, they are solid, and they will be converted directly to the iodine by a sublimation process. But as I told you, the question, it's not between the carbon dioxide and iodine, which is statement about carbon dioxide and silicon dioxide. So this question is a little bit tricky, so you have to be careful. In the question 9, you have an article in a science magazine contains the following statement: it's lighter than feather, stronger than steel, yet incredibly flexible and more conductive than copper. So which form of carbon is being described? Buckminster fullerene doesn't conduct the electricity because it's like a ball and all the free electrons are trapped inside the ball, so there is no conductivity. Diamond doesn't conduct electricity also because there is no mobile electrons. All the electrons are used to form 4 covalent bonds with other 4 carbons. Graphene and graphite, what's the difference between them? A graphite, it's many layers of graphene. Both of them conduct electricity? Yes. Both of them strong than steel? No. Graphite, actually, it's between the layers there is very weak physical bond, which is van der Waals. So these layers can slip on each other. So this graphite doesn't fit with this statement. And graphene, actually, it's very light because one layer of graphite stronger than steel and also conduct the electricity, because in a graphene layers there is free electrons, they conduct the electricity. So the best answer is C. In the question 10, which equation has an enthalpy change of reaction which corresponds to the standard enthalpy change of atomization of chlorine? Atomization of chlorine. So according to the definition, you have to produce 1 mole of a gas from 1 mole of the element at as gaseous state. So this statement, it's fit to the option. Which option? Let's check it. Here you have gas to gas. Yes, correct. So this one, you have 1 mole of gas atom which is formed from 1 mole of molecule at standard condition in a gas state. So hey, in an experiment, 2 mole of hydrogen and 3 mole of iodine were heated together in a sealed container and allowed to reach equilibrium at fixed temperature. The container had a fixed volume of 1 cubic decimeter. At equilibrium, there were 2.4 mole of iodine present in the mixture. Here you have hydrogen, you have 2 mole. Here the number of mole equal to the number of the concentration of these contains, because the volume is constant, so you don't need to convert the number of mole to the concentration. So 2 mole you have here, and iodine it's 3, and before starting the reaction we don't have Hi, so it's 0. At the equilibrium, 2 minus x because you have 1 mole of hydrogen, and iodine it's 3 minus x because also 1 mole of iodine, and we have produced 2x. Why? Because 2 it's 2 mole. This 3 minus x equal, because this is at equilibrium, this one at equilibrium, so this 3 minus x equal 2.4. That means x equal 0.6. So here you have 2.4. Here you have 1.4. And here you have 1.2. Kc equal product over reactant 1.2 square, sorry, yeah, this one should be square, over 1.4 times 2.4, and this one it will give us, by make calculation of this one, 1.2 square over 1.4 times 2.4, and this one it will give us Kc equal to 0.429. And the next question, let's remove this one first of all. Okay. Here consecutive elements x, y, and z are in a periodic, in the period number 3 of the periodic table. Element y has the highest first ionization energy, and he is talking about y and the lowest melting point of these 3 elements. So let's check the periodic table first of all. Okay, in the period 3, Sodium, magnesium, option A, sodium, magnesium, aluminium. Actually, the melting point of aluminium, magnesium, it's not lowest here. The sodium is the lowest, so this one it's wrong. Magnesium, aluminium, silicon. Let's check the why aluminium is the lowest. No, actually here the magnesium is the lowest melting point, so this one also wrong. Aluminium, silicon, phosphorus. The lowest melting point is phosphorus, not silicon, so this one also wrong. Here let's check the silicon. Phosphorus, yes, has the lowest melting point because silicon, it's giant covalent, so this is the highest. Why is phosphorus has the lowest melting point? Because phosphorus is exists as P4 and sulfur S8, so clearly this one has lowest melting point. Now, what's the first ionization energy? Highest. Why? Because if you can see that from the periodic table, silicon, phosphorus, sulfur. This one, silicon, phosphorus, sulfur. The ionization energy is increasing as you go from left to right. Yes, it's correct as a general trend. So this is the lowest, then phosphorus. But why sulfur has less ionization energy than phosphorus? Because here we have transferred, because we have spin repulsion in the sulfur. In the phosphorus you have 3 single electrons, but in the sulfur you have spin repulsion. So the ionization energy of sulfur is decreased and become lower than phosphorus. So the best answer is D. In the next question we have when dealing with the spillage of metal like sodium, that means you need to discard this sodium. It's important that no toxic or flammable products are formed. Now, dilute hydrochloric acid, HCl, with sodium, you will form hydrogen gas, which is flammable. If you will add ethanol, C2H5OH plus sodium, you'll produce also hydrogen gas, which is a flammable gas. Water spray, H2O with sodium, you will form sodium hydroxide and hydrogen gas, also it's flammable gas. So the best answer is sand. So if you have sodium and you need to discard it, you need to throw it, so you have to mix it with a sand. Here chlorine gas is widely used to treat contaminated water. Which species is present in the water when chlorine gas has been added is responsible for killing bacteria? Actually nowadays most of the people, they are trying to synthesize or preparing their solution to kill the bacteria and to kill also coronavirus. So they are actually mixing chlorine gas with H2O to form this one, because H2O plus chlorine, this one should be in a cold condition. Just you add them, you will form HCl plus HOCl, hypochloric acid. And the last question for this episode, which row of the table is correct? Ammonia molecule, and ammonium ion. Okay. So pyramidal, this one pyramidal, and this one regular tetrahedral, and the type of bonds between all of these atoms actually sigma bond, which is formed by sharing one electrons from each atom. So the best answer is A. Why it's not B? Because here is correct tetrahedral, correct sigma, but here we don't have, so this is wrong. So we have arrived to the end of this episode. So I hope you have learned the new things, and I hope you have learned how to solve the past papers, and I hope from you to follow my way to solve, to analyze each option, because we don't need to know the best answer only. Also, we need to know why this is wrong, because this way it will help us to analyze the other questions. Maybe the question comes but in a different way, so you will get the best answer quickly to save your time, because we have very limited time in the past paper. So thank you for listening and watching actually, and see you in the next episode.